So example 4 looks at the function, and we're eventually going to graph it, but that's not our first step. So step A is just writing the reciprocal. And when you're asked for the reciprocal of the function, you are asked to literally write the formula. So in this case, go 1 over, remember the definition is 1 over f of x. So in this case, it's going to be 1 over x squared minus 9. For part B, we want our non-permissible values, so where our denominator is equal to 0. So when x squared minus 9 equals 0, or cannot equal 0 rather. So x squared cannot be 9, so x cannot be positive or negative 3. So that's my answer for B. C is asking for my x-intercepts and my y-intercepts of my reciprocal function. Okay, so remembering that x-intercepts are when y equals 0, but remember that we also always have a horizontal asymptote at y equals 0. We are going to have no x-intercepts. Now this is going to be true for grade 11, not grade 12. Okay, so you could always double check, but at no point is that going to be possible. For my y-intercepts, that's when x equals 0, I can still plug that in and solve for it. So y equals 1 over 0 squared minus 9. So negative 9 in the denominator, so it's negative 1/9 is my y-intercept. Just like my non-permissible values are those. Once I have this all known, then I can graph both functions. So I'm just going to sketch again because that makes my life a little bit easier. So we've got non-permissible values at positive and negative 3. So 1, 2, 3. Asymptote here, asymptote here. Remember, when we list our asymptotes, we give them their name, not that they can't be equal to. Non-permissible values are not equal to those. Asymptotes are equal to those values. Okay, now going back to my original equation, I do need to graph f of x as well, so I'm going to graph that in red. And when I look at that equation, it's x squared minus 9. So my vertex, if I think about this in vertex form, which again is y equals a x minus h squared plus k. So we go, and we use p and q, sorry, minus p squared plus q. I've got p equals 0, so I'm not shifting left or right, but I am shifting downward to negative 9. So this is like 4, positive 4. Okay, so I'm giving myself a scale there. So I know that my vertex is here, my x-intercepts are here because that ends up being where my asymptotes are, so y has to be 0, and from here I can sketch out my parabola. Okay, so that is f of x. We've then got our reciprocal. We know our intercept is at 1/9, like so. It's going to go like this. Again, you could use a table of values if you want. more points, but the general shape is going to stay very close to all the asymptotes. So again, x that equals -3, x equals +3, and y equals 0 are all my asymptotes. Up here, it's positive. I'm going to get an invariant point when my graph equals 1. It's right there. My output's 1. Same thing over here when it equals 1. I'm going to get that invariant point. And scoops outward like that, never crossing that asymptote. And there we go. That's how we graph our reciprocal and our original function.